Question 2. So now you want to check between the leadership effectiveness scale between the managers and the executives. So you send out a mildly different survey that measures what these guys think about the leadership of their place. So first thing I did, like always, is I put it into an Excel spreadsheet. Hold on a second. Let me adjust. No better. So I'm going to run a t-test. I'm going to pick a cell, any cell, any cell. I'll take that cell. I'll go to the function bar. And t-test, right? That's under statistical. Go to t-test. First array. Let's put this out of the way here. Click and drag. Click. Click and drag. All t-tests from our class is just going to be a two-tailed t-test. I'll just make that simple for you. And again, this is not a paired t-test because the sample sizes are different. So we're going to mark in 2 and assume that the variance is close to the same in each group. Click OK. That's our p-value. It is greater than 0.05, so there is no significant difference. So we should get the exact same results in SPSS. So let's go find out. Hold on. I'm going to use the same SPSS SAV file, input file, that we did before, but I'm going to change the groups. Right, one's managers, 2 staff. I'm going to change 2 to executive. E-X-E-C-U-T, executive. And I'm going to change it. Okay, everything else is still the same, right? It's still a categorical variable for group. Leadership is still a scaled number, but now let me go back and change the data. I'm just going to cut and paste it from the Excel spreadsheet into this. Please hold. Okay, it's all cut and pasted. First thing I want to check is, what do I want to check? I want to check the assumption of normality. So I'm going to go to Analyze, Descripto, Exploro. And again, what I want to check is leadership. Make sure the scores are not abnormally skewed or anything. I'm going to check statistics. I want the descriptives because I need the means and the standard deviations when I write the results up in APA formatting, and I'm looking for outliers. Plots. Histogram will tell me about normality. I'm going to not use that one this time. See what kind of options. Case-wise don't need. Click OK. Boom. Okay, so remember, we're still checking for normality. So 25 cases, nobody's missing. Again, the skewness is not perfect. So remember, skewness is whether it kind of leans to the left or leans to the right. Kurtosis is how spiky it is. In other words, it either has too many people in the middle or not enough people in the middle, and it kind of is awkward, to say the least. So, but we're in acceptable ranges here. There are extreme values. Again, that doesn't necessarily make them an outlier. But here's the histogram, and I'm going to say, wow, that is pretty darn normal. Normal enough for me. Okay. According to the box plot, there are a couple of outliers. This would be member number 3, member number 8, and 18. So 3, 8, and 18. Let's go back and look at the data real quick. 3, there's a 19. Wow, that's pretty big. 8 is another 19. And I bet you 18 is another 19. 18, no, 18 is a 4, right? So it's too small. Those are outliers. We have the option of throwing them out. But, you know, I'm looking at the data, and they are part of the data, so it just means that you got a couple extremes on one side and one extreme on the other, so it kind of balances out. I'm going to go ahead and run my t-test as is. Going to go to Analyze, compare the means with an independent t-test. Again, leadership is my DV. And the grouping variable is group. You have to define the groups, right? Again, we had a ones and the twos. Just click OK. Here comes the results. Da, 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 da. So there's the means of the managers, means of the executives. Their standard deviations are relatively close to each other, so we're going to assume that the variance is the same. And don't look at the F, but we do look at the T. Okay. So we got a t-test statistic of about 1.6, which is not greater than 2, which means you're not going to get a significant difference. There's your degrees of freedom, and there's your significance, and it agreed with the Excel output about 0.12, which is greater than 0.05, so you do not get to reject the null. It's not that the null is still true or untrue, it's just that your data did not support that. And here's another way when you know to reject the null hypothesis. If your confidence interval, which is where you're trying to trap the true mean difference between the groups, if your confidence interval has a 0 in it somewhere, remember you just look at this as a number line. Negative 0.669 is on the left of 0, and 5.27 is on the right of 0. The number 0 is in this category, so that could be the difference, and that means that's exactly what the null is stating, that there is 0 difference between these means. So again, if your confidence interval contains a 0 in there somewhere, if I can fit a 0 between these two numbers, then you cannot reject the null. But that's it. Oh, wait, hold on. The answer to question number 3 is a one-way Anova with no repeated measures, right? You would be comparing 3 little groups, subgroups, the staff, the managers, and the executives. So there's your IV group, and there are at least 3 groups, subgroups, and your DV is their leadership score. So that's it. MGZ.